Hari Om. Last video we have seen current, electricity, then we have seen potential difference. So in this video we will see about what is the relationship between current and potential difference. Correct? So potential difference, what we have seen, potential difference, we have seen that there is a work by charge. So if there is any work to transfer a charge from one place to another place, what will happen? Potential difference will be there. And current is flow of charge per unit time. Correct? So Ohms was the scientist, physicist, who said first time that there is a relation between potential difference and current. And what he said that the potential difference across the ends of given metallic wire in electric circuit is directly proportional to the current flowing through it. Means very simple. Potential difference is proportional to current. Now, when we say potential difference, we represent V. And mathematically proportional means what? This sign. Correct. Potential difference is proportional to current. Now, simple. This was very unique and very famous rule that time, because he has proved it this, that potential difference if you increase, then current will increase. Like if you have 12 volt battery, 6 volt, 12 volt, 24 volt, 36 volt. So when you increase the potential difference, the capacity of the battery will be designed by what? This all voltage. So when you take more voltage battery, more potential difference, current you can get more, right? So that's how he was the first who said this one, that relationship between potential difference and current. He said more potential difference, so more current, right? Any doubt in this? Now we know that if we say proportional, okay, but we need to equate. We have to see the relationship and we want equation. So V equals to I and some constant, right? We use in math some
R is
constant. R is constant. V is proportional to I. If we want to keep it constant, both equal, what we have to do? We have to use this one, R. R is constant. Okay. So now we got very important relationship V equals to IR, which is now in exam and all one question definitely 100% will ask from Ohm's law. 100% is very useful in 12th standard also it will come. Right? Now how to derive this? How to derive this relationship? So what they have done in lab, they have taken the different potential difference battery and they have plot the graph between potential difference and current. They got it linear. Okay, at constant temperature, this is important. Temperature remains same. If you increase or decrease temperature, then this linear graph you will not see. Understood? Huh? This linear graph represents proportionality, right? So we can say that potential difference, this is V and this is current. So when you see VI graph, correct, it will be like this only. Okay, so this also is one formula we got. So first formula current we have seen, I equals to Q by T. Second formula, potential difference equals to W by Q. And this is the third formula, V equals to IR. V equals to IR, in that V is potential difference, I is current. What about R? No, this is interesting.
Constant.
R is constant. But what is R? Resistance. What we say? Resistance. Now in one wire, if you have suppose 5 wires, one is silver, one is copper, one is aluminium, one is gold, and if you pass current, okay, current will be same or different? Different, right? Correct? Current will be different. So why it will be different? Although you attach same potential difference, but you are getting different current. Correct? Potential same battery, but current will be vary. The reason is the wire, right?
The flow of current
Correct.
depends on
The wire means the flow of current. So different conductor will have different flow. Correct. So that only is resistance. Now have you heard about supercomputer? Supercomputer they use gold. Okay. Supercomputer they use gold wire because they want minimum resistance, zero resistance. Like that, ideally it's not possible zero resistance, but they try to minimize the resistance. Resistance means which doesn't allow electrons to flow. Like insulator. Insulator will not flow on, in charge will not flow in insulator. That's why we say it will never transfer current. But when you take another thing, suppose copper or aluminium, okay, or silver. Now compared to copper and silver, which will allow more electron to flow? Silver. Why? Because resistance is less. So resistance is nothing but it is the opposition in flowing of charge. So when charge flows through a conductor, so the opposition, it will oppose. The property which oppose the flow of charge is called resistance. So any doubt in resistance? Now in question and all, direct they'll ask. See this question you can see V equals to IR, right? V equals to IR. If V equals to IR, then what will be the current value? If you see the V equals to IR, correct? So what is R value? V by I. So many times in this chapter later you will see that we use resistance, we get resistance by V by I. Means if you have voltage, now in this house potential difference is 220 volt. In your house also 220 volt. Correct? In India, in domestic, for domestic circuit, potential difference how much we take?
220 volts.
220 volt. Correct? And current, suppose I am using this DC volt, suppose this is taking 4 ampere current. Correct? So like that, current will be 4 ampere. They may ask you the resistance, like that. Current is there, so what potential difference by current will be resistance. Okay? Sometimes they will give you R. They will give you I, they'll ask V. So V will be IR, I into R. Sometimes they will give you V, R, they'll ask I. So what will be I?
N by R.
V by R is I. V by R is I. Like that, this formula is important. Any doubt till here? No doubt? Now, this one, okay, V equals to IR. Now that resistance we have spoken about, right? Resistance. We want to see more about resistance. Like how it depends, in which factor it depends. So, resistance, current where it passes, suppose we have wire, right? So, wire will have length and thickness. Thickness means area. Suppose this is the wire. So, this part is area and this is the length. Correct? So, resistance depends on what? Length, area and nature of material. Right? Suppose we want, suppose in geyser or washing machine, the wire you may, or refrigerator, you have seen that wire is thick, right? Why wire is thick? Because more current is required. So more current means we give more thicker wire, right? So we'll try to understand that resistance depends on what all. Correct? V equals to IR, we understood there is something called resistance which opposes the flow of charge. Now we want to know that what actually resistance, on what parameter it depends. So resistance is nothing but, what is resistance? Geometrically, like R, we say is directly proportional to length. If you use common sense, you'll understand. Suppose you are going to watch movie in theater, correct? And book my show option is not there. You have to go and then you have to buy the tickets. Correct? Now first show, some famous actor. Okay, what will happen once you go in movie theater and if you find counter, only one counter is there. Okay, so current basically means it has to pass through wire, right? So current means when electron will pass, that is only current, right? Correct, huh? So if the current will pass like this, we say, if charge will pass like this, we say current. And resistance is directly proportional to length. Why? Because I have given example of movie theater. If you go there and only one counter is there, for you is it easy to go and enter to the hall, movie hall? No. Why? Because more resistance. Why more resistance? Length is more. So like that only, electrons has to go from one end to another end. Like how you have to go, there will be many people, right? So you have to go, take ticket and go inside. So you have to cross, right? That you are flowing. Like that, if electrons start flowing, we say that is electricity. Charge is flowing, so electricity. Now if length is more, is it easy to go or it is difficult to go? Difficult, right? If length is more, it's difficult to go. That's why we say it has more resistance. Understood? Clear? So resistance directly proportional to length. If length is more, length of the wire is more, resistance will be more. Similarly, here what we say that if area you increase, suppose the same movie you go to another theater, there are 10 counters. What will happen?
Resistance will be less.
There will be less opposition. You just to go buy the
ticket.
ticket and enter. It is smooth process, right? Going and coming smooth. That's why we say resistance is inversely proportional to area. Correct? So if area is more, resistance will be less. Correct? See, resistance means the opposition, oppose. So if area is more, resistance will be less. And if length is more,
Resistance will be
more. Simple?
Yes.
Correct? And only will it depends only length and area. If you take copper, gold, same length, same area, will resistance will be same? No. So it also depends on nature of the material. Since it depends on the nature of material, that we call rho. What we call? Rho. We say rho. So there will be formula R equals to rho L by A. This is the formula for resistance. What is L?
Length.
What is A?
Area.
And what is rho? Rho depends on nature of resistivity. What we call?
Resistivity.
This resistivity. Rho is resistivity. Resistivity. And what it depends? It depends on nature of material. So this formula, with this formula, many questions will come. R equals to rho L by A. What is L? Length. What is A? Area. Rho is resistivity. So using this formula, you can get many questions. R equals to rho L by A. And what will be rho? If you want rho, so A will go this side. SI unit will be ohm.
AR by L is
SI unit of resistance is ohm. Ohm we write like this. Okay, ohm. So this symbol is there, na? SI unit, this one. This we say ohm. This is SI unit of resistance. Understood? Any doubt in this? No? Understood? Rho L by A. Now if they ask rho, so rho will be here, A will go here, so R.
RA by L is equal to.
So rho equals to RA by L. And if they ask SI unit of rho, see R SI unit is ohm. Area SI unit meter square. and length meter. So SI unit will be SI unit of resistivity is what? Ohm meter. Ohm meter. Simple it is. So based on this, you can solve questions, numericals. Okay. Any doubt?
No, sir.
You can see many numericals in NCRT based on this rho L by AC, R equals to rho L by A. And then they have given, in NCRT, they have given the resistivity, because resistivity depends on nature, material. So material, see silver, resistivity is 10 power minus 8. If you see alloys, and insulator, you see resistivity 10 to the power 16 order. Means resistivity is so much, means charge will not flow. It's difficult to flow, right? And resistivity also, you can say that if you take, what is resistivity, how you define? If you take 1 meter length and 1 meter square area, okay, so the resistance of 1 meter wire and 1 meter square cross section, okay, area, what is the resistance? That will be only resistivity. Like what? Simple, see here. Rho equals to what you have written? See, R equals to rho L by A.
Rho is
So-
equal to RA by L.
Now, rho equals to RA by L. Here, if you want 1, correct? 1, if you want here, so what should be this R1? What should be area? 1. What should be length?
1.
Simple. So when 1 ohm resistance across 1 meter square area of 1 meter length will give you 1 ohm meter, means resistivity 1 ohm meter, right? So like that they'll ask, it's easy to solve. If you see many questions, see V equals to IR, direct question, V equals to IR. This question they have given 1 meter length. Resistance, how much they have given? 26 ohm. And diameter they have given 0.3. So with the diameter, why they have given diameter? Because area you have to find. And what is area of cross section? Pi r square, right? Circular, it is circular, right? And area of circle is pi r square. So pi r square if you use, you will get answer. So that's how you can solve many questions. Okay. So next part we will see the combination of resistors. So in this video we have seen about the Ohm's law and the resistance. Okay. Next video we will see the combination of resistance. How we can combine in parallel, we can combine in series, we can combine. That is very famous, combination of resistors. Okay. I hope it is clear. Keep learning, keep shining. Hari Om.